Hello, I'm Trevor. I run the Chem 2 AEWs here on campus, and today I'll be talking about rice charts. This is a method of finding equilibrium concentrations and other information about equilibrium reactions. This could be acid-base, or this could be a number of other equilibriums. Here we have a gas phase equilibrium, where indium and hydrogen form a compound. We're given a Kp at a given temperature, and we're given the initial concentrations of the three of these species. So the question is asking to find the final or equilibrium concentrations of these species. We can do this with a technique called a rice chart or an ICE chart. This stands for reaction, initial, change, and equilibrium. So we'll write in the reaction first. Indium plus hydrogen. Oops, sorry. That is mercury. Hydrogen goes to indium hydride. So here's a reaction. And the initial conditions are given by the problem statement. We have 760 torr of indium hydride, 12 torr of indium, and 14 torr of hydrogen. So these are our initial conditions. There's going to be some change, and that will give us an equilibrium value. We can calculate this change knowing the relationship in the stoichiometry. This is a 1:1:1 ratio, so if we were to use one of these and one of these, we would make one product. Here, we know that the reaction is going to go backwards from the initial conditions by calculating a Q factor, or sorry, Q is a quotient. Q has the same equation as Kp, but Kp is at equilibrium and Q is this reaction quotient, not at equilibrium. So written the same way, Q is products over reactants, so this is the pressure of INH2 over the pressure of H2 times the pressure of indium. So we can calculate this Q and compare it to Kp. And if Q is bigger than Kp, that means the numerator or the products are larger than Kp should be, and the reaction should go backwards. And that is the case we see here. I won't do the calculation to save time, but I will give you the results here. That means we know that we must add to the reactants and take away from the products. Now the equilibrium column is simply the addition of these two columns. Sorry, the equilibrium row is the addition of the two rows above it. So this would be 12 plus x, 14 plus x, and 760 minus x. So these are our equilibrium concentrations. Now we've gone from 3 unknown concentrations to 1 unknown change in concentration. We can calculate that pretty easily by saying that Kp, a known, is equal to these 3 pressures, right? So the pressure of indium hydride is 760 minus x, divided by the pressures of indium and hydrogen. So that's 12 plus x and 14 plus x. If we simplify this equation and solve for x, you have to solve a quadratic in order to do this. You solve for x and you get about 9.5. So now that we know x, it's a simple matter to add X to the two reactants and subtract X from the product in order to get the final pressures at equilibrium. For more questions on Rice charts or any other equilibria chemistry problems, you can come to my office hours 2 to 4 p.m. Mondays and Wednesdays in Casa, or my workshops 6 to 7 p.m. on Wednesdays in Brown West 210.